homework 2 from 5.2. If you change your mind, let me know. Oh, okay, number 4. All right. So this is a synthetic division problem because I see that the divisor has a leading coefficient of 1 and a degree of 1. So I'll start by setting that divisor equal to 0 and solving. So that -7 is going to be the number that goes on the outside of my synthetic substitution setup here. And then I'll take my coefficients from the divisor, and those will be the numbers that go in the synthetic substitution setup. So I have -4 for the x to the fifths, but I don't have any x to the fourths, so I need to put a 0 there. And I have a 7 for my x to the thirds, a -2 for my x squareds, a 5 for my x's, and notice that there's no constant term there, so I also need to make sure I put a 0 at the end as well. And now I'm just going to go through and repeat the synthetic substitution process. So I'm going to bring down the -4, and then -7 times -4 is 28. And I add that down, 0 plus 28. -7 times 28 is -196. And I add down 189. -7 times 189 is 1323. I add down is 1321. And then multiply that by -7 is -9,247. Add down, that's 9242. And I multiply that by -7. And I get 64694. So messy one here. So my remainder, constant term, my x coefficient, my x squared, and x to the fourth coefficient. So the way I'll write my final answer, -4x to the fourth, 28 x to the third, -89 x squared, 1321x, -9,242 plus my remainder over my divisor. Number 6 is 8x cubed minus 1. So since I see the x to the third and the subtraction, I'm going to start thinking this is a difference of 2 cubes. So I'm going to see, is there a way I can write 8x cubed as something cubed? Well, I know 8, 2 times 2 is 4, and times 2 again is 8. And x to the third is x times x times x. So I can rewrite 8 as 2x cubed. And 1 is the same thing as 1 times 1 times 1, so I can rewrite 1 as 1 cubed. So my a is like 2x, and my b is like 1. So if I use my difference of 2 cubes formula, I can write a minus b times a squared plus squared. And then if I simplify things down, 2x times 2x is 4x squared, 2x times 1 is 2x, and 1 squared is 1. So that would be my final answer there. Okay. Are there other questions from the homework past those two? Ava and Hallie, you're okay with what we did there? Okay. So let's go ahead and start the final lesson for the semester. So we've been talking about last sum and difference of cubes. And we talked about the difference of two squares. This time we're going to add on two more factoring techniques. By that, ax to the 2n plus bx to the n plus c. So let's look at an example of what I mean by that. Let's say we have the polynomial x to the 4th plus 5x squared plus 6x. So what I'm looking for is I notice that my biggest exponent is twice my other exponent, and then I have a constant term. That tells me that I have something in the quadratic form. So the trick here now is going to be to rewrite this as something that is actually quadratic so that I can factor it using the methods from the previous chapter. So I can rewrite x to the 4th as x squared squared, and I can rewrite x squared as x squared to the 1st. Is going to give me something quick. So I have something squared plus 5 times something to the 1st plus 6. I'm going to give that something the name y. And now I have something that's fully quadratic. So I can factor this like I would from last chapter. Since the leading coefficient is 1, all I need are two things that multiply to give me 6 and add to give me 5. So those two things would be 2 and 3. I can go straight to the factored form. But I don't want to factor y squared plus 5y plus 6. I wanted to factor x to the 4th plus 5x squared plus 6. So let's go ahead and put that value. And then I should just check to see if either of these two are factorable anymore. So I have x squared plus 2. I know that's not factorable because I don't have a sum. There's no factoring for sum of squares because of the plus sign. And similarly, x squared plus 3. There's no factoring for sum of squares, so that would be my final answer. Let's do another. So let's say I have x to the 6th minus 17x to the 3rd plus 16. Okay. So just like I did before, I'm going to check to make sure it's in the quadratic form. I see my biggest exponent is twice the next exponent, and then I have a constant term. So I am in the quadratic form. I want to rewrite x to the 6th as something squared. Well, I know x to the third times x to the third is x to the sixth. And then I can write x cubed as just x cubed to the first. And then I can make a substitution. I'm just going to replace those x cubes with y's. So I have something that's quadratic. So here I just need to find two things that multiply to give me positive 16 and add to give me negative 17. That would be negative 1 and negative 16. Shoot. I'm going to change this problem real quick. I made an oopsie. I want this to be 9 and 8. Sorry about that, guys. So now, since the leading coefficient is 1, those two numbers go and take me exactly to my factored form. But again, I don't want to factor y squared minus 9y plus 8. I wanted to factor x to the sixth minus 9x to the third plus 8. And then substitute back. And if I look at each of these, x to the third minus 8, that looks like a difference of 2, where my a is x and my b is 1. So when I apply my difference of 2 cubes formula, get that. And x cubed minus 8 is also a difference of x and my b is 2. So when I apply my difference of 2 cubes formula here, I get this. Any questions so far? Okay. The other factoring technique that we're going to talk about today is grouping. And we already know how to do factor by grouping. The quadratics using the full method. So let's look at an example. So like 1, 2, 3, 4 things that are being added together. That makes 4 terms. I'm going to make 2 groups. I'm going to look for a greatest common factor in the first group, which would be x squared. When I factor out the x squared, x cubed becomes x, and 3x squared becomes 3. Look at my second group, I look for a greatest common factor. That's 5. So 5x becomes x, and 15 becomes 3. Then if I look at this term and this term, I see there's a greatest common factor of x plus 3. When I factor that off, I see I have x squared plus 5. And then I should check to see if I could factor any of these anymore. X plus 3 is linear, so that doesn't factor anymore. And x squared plus 5, I have a squared, but it's plus, so there's no sum of squares, so I know I can't factor that anymore, so I'm finished. We'll do one more example, and then we'll finish up talking about solving. So let's say we have x cubed plus 4x squared minus 9x minus 36. So just like we've done, we're going to make 2 groups. But remember, when we make our 2 groups, we need to have a plus sign in the middle So I'm just going to turn that into plus and negative, so the negative sign goes inside the two groups. In the first group, my greatest common factor is x squared. My second group, the greatest common factor is negative 9. If I look at each term, my greatest common factor is x plus 4. And that leaves me with x squared minus 9. Now I should check if I can factor any more. X plus 4 is linear, so I know that doesn't factor anymore. But x squared minus 9 is a difference of two squares. So just like we would have factored this in the previous chapter, I can write that as x minus 3 and x plus 3. And now that everything is linear, I know there's no more factoring to do. So we're done with that one. So just as a summary, if I have two terms, I'm going to be looking at the sum or difference of two cubes or the difference of two squares as the way to factor it. If I have three terms, I'd be looking to try to use the quadratic form to factor it. If I have four terms, I'd be using grouping to factor that. Just to summarize what we did there with the factoring. Solving polynomials. So we're right. Get so we'd want to factor, and then we're going to use the zero product property to set each factor equal to 0. Each one separately. Notice that in order to do any of these solvings, we're going to have to factor. In the interest of time, what I'm going to do is I'm going to go back and look at these previous four examples that we just did and turn them into solving problems and steal the work we did to factor them, so I don't have to redo that work. So we're just going to be a little bit more efficient with our time. So I'm just going to scroll up. So let's assume that this was a solving problem. So I'll see the equals 0. That's how we know it separates it from a solving problem. The first thing I'd do is make sure it's equal to 0, which it already is. So then I'm going to factor it. And I'm just going to steal the work that we did in that previous example to get the factored form. And then I'm going to take each of these factors and set them equal to 0. And then I can solve each one of these independently. So x squared plus 2 is a quadratic that I can solve directly. So I'll just subtract 2 from both sides and then square root both sides. Because I square rooted both sides, I get a plus or minus. Because I'm square rooting a negative, I get an I. And the square root of 2, there's nothing to do, so I'll just write that as 2. Similarly, here, x squared plus 3 I can solve directly. So I'll subtract 3 from both sides, square root both sides, and just like plus or minus, I square root 3. Any questions on what we did there? Alrighty. And looking at this next one. So again, let's problem this time. So the first thing I would do is get it equal to 0, which it already is, so there's nothing to do there. So now I need to factor it. Which I'm going to just steal the work from that to write it in a factored form. And now I'll use the zero product property to set each of these factors equal to 0. So to solve x minus 1 equal to 0, I can just add 1 to both sides. To solve x squared plus x plus 1 equal to 0, that's a quadratic. But I can't solve this quadratic directly because it has both x's and x squareds in it. And I can't factor it because there's not two numbers that multiply to give me 1 and add to give me 1. In fact, this quadratic part that comes from the difference of, or sum of two cubes is never going to be factorable. So I'm going to use the quadratic formula to factor it. So negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So 1 minus 4 is negative 3. And then to square root a negative, I take out the negative and replace it with an I outside the radical. And I can't simplify anything more, so that's just going to be my final answer there. X minus 2 equals 0, we'll just add 2 to both sides. And then similarly, x squared plus 2x plus 4, we're in the same predicament as x squared plus x plus 1, where it's not factorable. So we'll just use the quadratic formula again. So 4 minus 16 is negative 12. And negative 12, I can take out an I. And the square root of 12, well, 12 is 4 times 3. So the square root of 4 is 2, and the square root of 3 we can't do anything with. And then I notice that each part has a factor of 2, so I can reduce that to just be negative 1 plus or minus I root 3. So those are my answers. Notice that each part is giving me an answer. In addition, I should mention that these pieces that are the quadratic part that we're getting from the sum or difference of two cubes, not only are they never factorable, they're also always going to give us imaginary solutions as well. So that's good to know that you should be expecting to get imaginary solutions from those quadratic parts from the sum or difference of two cubes. Always. Okay. Moving on to the next example. So it's already equal to 0, so I'm going to factor it. For this problem example, to factor it. And then I can set each piece equal to 0 and solve them separately. So subtracting 3 from both sides. And quadratic that I can solve directly, so I'll subtract 5 from both sides. Square root both sides. So that gives me the plus or minus from the square rooting. The I from the negative underneath the radical. And I can't do anything to simplify the square root of 5, so I'll just stop there. So those are my answers for that problem. And the last one, x cubed plus 4x squared, x minus 36 equal to 0. Once again, it's already equal to 0, so I can just factor it. So rather than doing that work all over again, I'm just going to steal the work that we did in that previous example. And I can set each of these factors equal to 0 and solve each one of them independently. So subtract 4 from both sides, add 3 to both sides, and subtract 3 from both sides. And those are my solutions. That one turned out to be the easiest solving problem because all of the factors were linear. They just had x's, there were no x squared, so it made the solving a little bit easier. Overall, these topics should feel relatively familiar because they're all very, very similar to things that we did in the previous chapter on quadratics, right? The solving that we're doing, each of these little solving problems is either linear or quadratic. So they're doing things that we've already done. Factor by grouping, we already did when we factored quadratics in the previous chapter using the full method, the long way. And factoring with the quadratic form is basically just using our quadratic shortcuts that we used, or the quadratic factoring techniques we used in the previous chapter, once we've kind of finagled our polynomial to look quadratic. So that's it here for what I wanted to do in Chapter 5 for this semester. Obviously, when we meet back again, we will review some of these topics and start all over again in Chapter 5. But your final homework assignment for Chapter 5 is this homework 3 that's already in the content library. It's 10 solving problems. So again, the first step you'd want to do is to make sure you factor these using the techniques that we talked about already. Then you set each factor equal to 0 and solve each of these factors independently, just like we did in the examples. Okay. Any questions about any of this before I let you guys go?
Are we gonna have like a final exam?
No. The only thing that you'll do on the final exam period is come in, check in for attendance, and if you elected to do one of the test retakes, you'll do that retake during the assessment period. But if you're not electing to do that, if you're just going to take the doubled high test score, then you'd be free to go after we kind of do attendance.
Okay, thank you.
You're welcome. And reminder, Tuesday is our assessment period. And if you were planning on trying to do one of these retakes, you need to email me here like ASAP. So if you wanted to do one of the retakes, you can do that. It's your option, but you need to email me as soon as possible. If you don't, I'm just going to give you the doubled high test score, which is already entered in on Net Classroom right now, so you can see where things are at right now. If you don't think that's high enough and you think you'll get more points from potentially doing the retake, you're welcome to do that. Okay?